welcome back. Now that we have the language of factors and multiples, let's move on to one of the most helpful visual models for this topic, rectangular numbers. Imagine we have these square tiles and we want to arrange them into rectangles. Let's begin with 6 tiles. How many rectangles can we make? We can arrange 6 tiles as a 1 by 6, a 2 by 3, a 3 by 2, and a 6 by 1. So we have 4 possible rectangles. 1 by 6, 2 by 3, 3 by 2, and 6 by 1. Note that some people would group these into factor pairs. 1 and 6 are together, and 2 and 3 are together. But when we think about arrays with orientation, 2s by 3s and 3s by 2s can look different, so both must be shown visually. Now, let's show rectangles with 7 tiles. We can only make 1 by 7 and 7 by 1. That means 7 only has one factor pair, 1 and 7. This is one visual cue that 7 is prime. In fact, this will happen with all prime numbers. There will only be 2 possible rectangles. One that's short and long, and one that's really, really tall, but very narrow. Next up, let's look at rectangles with 8 tiles. Here, we have a 1 by 8, a 2 by 4, a 4 by 2, and an 8 by 1. So, 8 has 2 factor pairs, 1 and 8, and also 2 and 4. Now, let's show rectangles that we can build with 9 tiles. For 9 tiles, we actually have 3 rectangles, 1 by 9, 3 by 3, and 9 by 1. This one is interesting because it uses a 3 by 3 square. It uses the same factor twice. So now let's connect all of our tiles to prime and composite numbers. A number is prime if it can only be arranged into a rectangle with 1 as one of the side links. In other words, it only has one factor pair, 1 in itself. A number is composite if it can be arranged into at least one other rectangle besides 1 by itself. So 7 is prime because only 1 by 7 or 7 by 1 worked. But 8 would be composite because that one had a 2 by 4 rectangle. 9 would also be composite because it has a 3 by 3 rectangle. But now, let's think about a deeper question. How can we tell if a number has an even or odd number of factors? In the case of 9, we had an odd number. What made that happen? Most factors come in pairs. For example, with 8, 1 goes with 8, and 2 goes with 4. This gives us an even number of factors, 1, 2, 4, and 8. But what about the number 9? 1 goes with 9, and 3 goes with itself, another 3. So the factor 3 does not pair with a different number. That gives 9 an odd number of factors, 1, 3, and 9. This happens when the number is a perfect square. These are going to be numbers like 4, 9, 16, 25, 36, etc. So here's the big idea. Most numbers have an even number of factors. Perfect squares have an odd number of factors. Why? Because one factor is repeated in the middle. Now, let's apply this to some larger numbers. With the rectangles of 248, will we have an even number or an odd number? Well, We want to know whether 248 is a perfect square, and it's not. We can't multiply a whole number by itself and get 248. So its factors will pair up with different partners. So the number of the factors in this number is even. The number of rectangular arrangements, if counting both orientations, will also pair naturally. What about the number 196? Well, this can be written as 14 times 14. So this number is a perfect square. That means it'll have an odd number of factors, since 14 will pair with itself. This is such a beautiful connection between arithmetic and geometry. Arrays let us see factor structure instead of only computing it symbolically. As teachers, this matters because many students understand multiplication and factors better when they can build or draw them. Rectangles are not just illustrations, they are mathematical reasoning tools. You are building exactly the kind of understanding that helps students move from memorizing to making sense. In the next video, we'll look at a classic method for finding prime numbers.